Hi, my name is Ashish, and in this video we will see behavioral blocking and containment capabilities in Microsoft Defender for Endpoint. First, I'll give you an overview. So today's threat landscape is overrun by fileless malware, and that lives off the land, highly polymorphic threats that mutate faster than traditional solutions can keep up with. And then there are human-operated attacks that adapt to what adversaries find on compromised devices. Now, if you talk about traditional security solutions which are not sufficient to stop such attacks, we need artificial intelligence and device learning, which is part of machine learning, backed capabilities such as behavioral blocking and containment, which is included in Defender for Endpoint. So you can say that this behavioral blocking and containment are the capabilities of Microsoft Defender for Endpoint, which are backed by artificial intelligence and device learning. What they do is, what it does it can help identify and stop threats based on their behaviors and process trees even when the threat has started execution. Now we have next generation protection, EDR, and Defender for Endpoint components and features. Those work together in behavioral blocking and containment capabilities. Now if you talk about the how to set up this behavioral blocking or configuring this behavioral blocking, I'll log on to the portal. We can do it through attack surface reduction rules as well. Those are ASR. And we can do it for Defender for Endpoint baseline. Defender devices are onboarded to Defender for Endpoint. And make sure that if your organization is using Defender for Endpoint, client behavioral blocking is enabled by default. Now, however, to benefit from all Defender for Endpoint capabilities, including behavioral blocking and containment, make sure that the following features and capabilities of Defender for Endpoints are enabled and configured, which are Defender for Endpoint baselines. Devices should be onboarded to Defender for Endpoints. EDR in block mode should be enabled, which is endpoint detection and response. And then we talk about next generation protection, which is antivirus, anti-malware, and other threat protection capabilities. Now, when you talk about containment capabilities, there are some components of behavioral blocking and containment, which are on-client policy-driven attack surface reduction rules, which are predefined common attack behaviors are prevented from executing according to the ASR rules that we will set up. Now then there is client behavioral blocking, which are threats or endpoints which are detected through machine learning and then are blocked and remediated automatically. Then there is feedback loop blocking, also referred to as rapid protection. Threat detections are observed through behavioral intelligence. Threats are stopped and prevented from running on the other endpoints. Feedback loop blocking is also enabled by default. Now there are some examples of behavioral blocking and containment in action, which are credential dumping from LSAS, cross-process injection, process hollowing, user account control bypass, tampering with antivirus, contacting command and control to download payloads, coin mining, boot record modification, pass the hash attacks, installation of root certificate, exploitation attempt for various vulnerabilities. And if I want to show you an example of credential theft attack, there is a Microsoft documentation or an article available wherein AI-driven behavior-based blocking stops attack in their tracks, right? So let me share that link with you. I'll open it up right now. This is the article that I was talking about. In hot pursuit of elusive threats, AI-driven behavioral-based blocking stops attacks in their tracks. Now, this is the latest article that they were talking about. It talks about a credential theft attack against 100 organizations around the world was stopped by behavioral blocking and containment capabilities. Now, spear phishing email messages that contained a lewd document were sent to the targeted organizations. If a recipient opened the attachment, a related remote document was able to execute code on the user's device and load Lockybot malware, which stole credentials, exfiltrated stolen data, and waited for further instructions from a command and control server. Now, behavior-based device learning models in Defender for Endpoint caught and stopped the attack's techniques at 2 points in the attack chain. The first protection layer detected the exploit behavior through device learning classifiers in the cloud, correctly identified the threat as and immediately instructed the client device to block the attack. The second protection layer, which helped stop cases where the attack got past the first layer, detected process hollowing, stopped that process and removed the corresponding files such as Lockybot. Okay, and these are the pre-execution detection engines, post-execution detection engines. How the two behavioral based machine learning protection enrich post-breach detections. Now, we got inside those alerts, there was the initial access behavior alert was generated, and it talked about how a malware and unwanted software, which are undesirable applications that might perform disruptive or harmful actions on the affected devices, and how these devices can replicate and spread from one device to another. Okay, and others are able to receive commands from remote attackers and perform activities associated with cyber attacks. This is where the behavioral blocking and client behavioral blocking comes into picture. And when you talk about feedback loop blocking, it is also referred to as rapid protection, is a component of behavioral blocking and containment capabilities in Microsoft Defender for Endpoint. And how it works is, now when a suspicious behavior or file is detected, such as by Microsoft Defender antivirus in Windows, information about that artifact is sent to multiple classifiers. The rapid protection loop engine inspects and correlates the information with other signals to arrive at a decision as to whether to block a file. Now, checking and classifying artifacts happen quickly. It results in rapid blocking of confirmed malware and drives protection across the entire ecosystem. And if you want to configure feedback loop blocking, now if you have Microsoft Defender for Endpoint, feedback loop blocking is enabled by default. However, rapid protection occurs through a combination of Defender for Endpoint capabilities, machine learning protection features, and signal sharing across multiple Microsoft security services, right? So you should have Microsoft Defender for Endpoint baselines. Devices should be onboarded to Microsoft Defender for Endpoint, EDR in block mode, attack surface reduction, and next generation protection antivirus. Alright, so I hope this was informative for all of you guys. If you have any further queries, please mention them in the comment section, and I will see you guys in the next video. Thank you. Have a good day.